Today I'm taking a look at the GOYOJO thermal imaging camera. So we got our instructions. It's using a vanadium oxide uncooled focal plane array. This one is the GH340, so it has 256 by 192. It's a frame rate of 25 Hz, has a field of view of 50 degrees, and it is a 3.3 mrad. That has two levels of measurement that can measure between negative 20 degrees to 550 degrees Celsius. That is actually very hot even for a thermal imaging camera. It has an accuracy of 2 degrees, measurement distance of up to 50 meters, default emissivity of 0.95, center point temperature, and it does have automatic high-low temperature. We can set a temp alarm. Got an adjustable temperature range, smart temperature highlight, thermal imaging, fusion, visible light, and we have 6 different color palettes. Got a 2.8-inch screen that can take photos. It has 8 gigabytes of storage, and the USB port is USB-C. For the battery, it uses an 18650, which is very good. That is a very common battery type. The operating time for the 340 is greater than or equal to 6 hours. Charging time of 4 hours, and charging at 1 amp at 5 volts. Let's come with our charging cable. That is USB-A to USB-C, and here is the tool. On the top, we've got our charging port. See both of our lenses there on the front. We do have a finger trigger, and we got our navigation buttons there on the back. Okay, so we are running. So right now it is detecting, you can see that crosshair in the center. So where that red and blue marker are, that is going to tell us the hottest and coldest zone. And if you look at the bottom right, we can see the max is at 34 degrees Celsius and the minimum is 18 degrees Celsius. So it's going to tell you exactly what it is reading at those red and blue points. Right now in the center, so where it is targeted at, we are looking at 31 degrees Celsius. So if I press the trigger, that is how we are going to be taking pictures. Oh, that's neat. So I hit up and we can see kind of an overlay, and it is calling this fusion. Here we can see visible light, thermal imaging, and fusion. Very cool. Sit down, and this is how we change the color palette. So we got rainbow, white hot, hot spot, black hot, red hot, fusion, iron red, and back to rainbow. Now, I really like the iron red, so I'm going to stick with that. If I hit the menu button, go to albums. So these are the 4 pictures that I took. So if you want to be able to take that and show it to somebody, you can. Emissivity, so right now we are at 0.99, but we can change that to whatever it is that is going to be most suitable for what we are working on. Palettes. So you can see them all on a list there. Distance. So if we know we're going to be working at a far distance, we can adjust that to better accommodate what we are actually looking at. Got display settings. Okay, so this is going to be basically the interface, the GUI that we had on the front. If we want to dumb it down a little bit, we can turn all this stuff off. Temperature alarms, so we can turn that on. So this is going to allow us to set an alarm, and I'm going to set that down so we can make that actually happen. So we'll say 22 degrees, and we'll go back. All right. And we can see that bell there on the top right, so we know we are alarming. We got temperature range. So if we want to look at really hot objects, we can set that to the hot, or we can set it to auto. So it'll automatically calculate depending on what we're looking at. And more settings. File transfer, so if we want to be able to take those pictures and transfer them to the computer, then we want to turn that guy on. Temperature units is in Celsius. If we want to, we can change that to Fahrenheit. Nice having that option. Brightness is 80%, so that is going to be the display. So if you want to save battery power, we can bring that down. I think the 80% look pretty good. Language, time and date, APO, about device, format memory, factory reset. So nice. Very easy thing to work with. What you're going to want to know is just turn the thing on and point it at what you want to look at. Nice and simple. So up here on these presses, you can see that pipe. One of those is way hotter than the other ones. It's kind of interesting. I don't know, the reason for that is just because this one was running and that one wasn't. But I never realized that there was that much of a heat difference between them. That is pretty interesting stuff. And these pipes are for our cooling. You can see those are considerably cooler. At least that way you can know that those are working. Right here, got that one box there at the bottom that is kind of cooking. Pop that guy open. And we definitely got some heat coming off of that motor. Depending on what I'm pointing at, get about 71 degrees. A lot nicer than going down there to touch it to see if it's hot. So on this machine, this is going to stitch staples into that paper, and we recently took one of those plates and we ground that down a little bit. What I'm going to look for here is if that's creating any extra heat. And it does not look like it is. So I mean the whole thing is warm, but we're not getting any hot spots.
That'd be something that would be impossible to see with a simple infrared thermometer when we had that little laser, just because that is moving way too fast. But with this, you can actually see it. Kind of cool. And of course, if you're doing troubleshooting on electrical circuits, that kind of thing, you can use that guy to find out what is getting hot, which quite often can help you identify what component is going bad. And there we go. That is where fusion can really come in handy, because quite often when you're looking at that, it is hard really to identify which component it is that you're actually pointing that camera at. Having that fusion can help you to really look and see what it is that you're looking at. Very nice. Yeah, that is something that you definitely do not see on most thermal cameras. So overall, that is a very handy tool to have around.